And how many of you know that there is a relation between frequency and atomic number? See here, Moseley gave one expression, that is Moseley's equation. The Moseley's equation gives the relation between frequency and atomic number, and also wavelength and atomic number. And in today's class, we are going to learn the details about all these things. Hi dear students, today we are going to discuss the relation between atomic number and frequency given by Moseley. And Moseley, he gave an expression. He gave an expression for the relation between atomic number and frequency. See here, atomic number given by Moseley. He conducted some experiments on discharge tube and he took unknown elements as anticathode. Anticathode is nothing but anode, and he discovered unknown spectrum, that is X-ray spectrum, and he understood that every element has different frequencies, means every element has a characteristic frequency. From that one he understood there are different elements with different frequencies, and he gave an expression, that is Moseley's expression. According to the Moseley's expression, the frequency of the spectral line in the characteristic X-ray spectrum is directly proportional to square of atomic number of the element considered. See here, Moseley he gave expression mu is proportional to z square. To equalize both the things, he used constants. Here A and B are constants, and these constants has definite values for definite element. Every element has its own fixed values for A and B. And we know that nu is nothing but c by lambda. We can write this one like root of c by lambda is equal to A z minus b, or you can write it as az minus ab. And see here, the relation between the frequency and constants and atomic number is expressed in terms of graphs also. Now we will check graphs. Now we will check the plots which are showing the relationship between frequency and atomic number according to the Moseley's expression. See here, there are three kinds of graphs are there. We will check one by one. If we consider first one, see here, if we are taking atomic number z minus the constant b on x-axis and frequency nu on y-axis. See here, these two are proportional to each other. That's why the graph is a straight line passing through the center. Okay, and here slope is the constant a. If you consider second graph, in second graph we will take in terms of wavelength, because there is a relation between frequency and wavelength. Frequency is equal to c by lambda. Here c is velocity of light and lambda is the wavelength of the spectral line. And see here, if you consider, see here, wavelength on y-axis and same atomic number minus the constant b on x-axis. Here these two are proportional to each other because it is reciprocal. Now because of directly proportional relationship, here also it gives a straight line passing through the center. See here, in graphs the general thing is, if two physical quantities are directly proportional to each other, it gives a straight line passing through the center. And here the slope is a by root c. Here c is nothing but velocity of light. And in case of third one, frequency on y-axis and atomic number, only atomic number. Here I am considering only atomic number on x-axis. See here it gives one intercept. Here it gives one intercept. Here intercept is equal to AB. Intercept is equal to AB and slope is A. Slope is equal to A, but intercept is AB. These are the three different plots which gives the relation between frequency and atomic number, wavelength and atomic number, and different constants and different slopes given by Moseley's expression. Okay, please note down these things. We will calculate a few numericals on these expressions. Now we plotted three different graphs for Moseley's equation, and here there is a calculation on one of the graph. See here, the frequency of the characteristic X-ray of K alpha line of metal target M is 2500 per second, means they gave frequency, and the graph between nu in the sense frequency and atomic number Z is as follows. Then atomic number of M is, they are asking atomic number of M. We have to find out atomic number of M. They gave the graph here. In the graph, nu, the frequency nu is there on y-axis and atomic number Z is there on x-axis. And see here, there is an angle of 45 degrees and there is an intercept OA is equal to 1. By using these values, we have to find out atomic number of M here. See here, what is the Moseley's equation? Moseley's equation, root mu is equal to A Z minus B. We can write this one as AZ minus AB. See here, what is the value of frequency here? They gave frequency as 2500. 2500. That is equal to A. See here, what is the slope here? Slope is A and it is tan 45 degrees. Tan 45 in the sense, what is the value? Tan 45 is equal to 1. 1 into Z minus AB. Intercept AB. Intercept AB is, they given it as OA is equal to 1. Root of 2500 is equal to 50. That is equal to 1 into Z minus 1. Therefore, Z is equal to 50 plus 1, that is equal to 51. What is the atomic number? The atomic number of the given target metal is 51. Okay, this is the way to calculate by using Moseley's equation from the graph. Okay, hope you understood this one. Please note down and we will move to next one. And see here there is a calculation. We have to calculate this one based on Moseley's expression. Once you check this one, find the wavelength of K alpha line for Z is equal to 41 when A is equal to 5 into 10 to the power of 7 hertz. See here, what is the Moseley's expression? The Moseley's expression, mu is equal to A Z minus B square. And see here, the value of A is 5 into 10 to the power of 7 hertz and atomic number Z is 41 and B value indirectly they given K alpha line. See here, for K alpha line, the B value is 1. Let us substitute the values. A is 5 into 10 to the power of 7 and Z is 41 minus 1. 41 minus 1, 40. We will write it as 5 into 40 into 10 to the power of 7 square. 5 40s are 200. And see here, if you write 200 in terms of 10 powers, then we will get 2 into 10 to the power of 9 square, and 2 2s are 4, and 9 2s are 18, 10 to the power of 18. See here new value is equal to 4 into 10 to the power of 18 hertz. Now we have frequency, now we have to find out wavelength. See here, wavelength lambda is equal to c by nu. What is c here? C is nothing but velocity of light in vacuum. What is the value of c here? 3 into 10 to the power of 8 meter per second. And what is the frequency here? 4 into 10 to the power of 18. 4 into 10 to the power of 18. If we simplify this one, 3 by 4 is equal to 0.75, and here 10 to the power of 18 will move to numerator and it becomes 10 to the power of minus 18, then we will get 10 to the power of minus 10. See here, if you write this one like this, 7.5, then it becomes 10 to the power of minus 11 meters. The wavelength of K alpha line for atomic number 41 when A value is equal to 5 into 10 to the power of 7 hertz is 7.5 into 10 to the power of minus 11 meters. See here, by using Moseley's expression, we can find out wavelength from atomic number, and in one more calculation we will find out atomic number using wavelength. We will check one more. In previous example we calculated wavelength using atomic number, and here by using wavelength we are going to find out atomic number. Let us check the given problem here. Find the atomic number. We have to find out the atomic number of the element using Moseley's equation when A value is equal to 5 into 10 to the power of 7 hertz and B value 1. See here, sometimes they will give B value 1 and sometimes they will give it is K alpha line. See here, when it is K alpha line, B is equal to always 1. Okay, keep that one. And see here, they gave wavelength of the K alpha line as 1 by 3 angstroms. Okay, we will substitute the values in the Moseley's equation. What is Moseley's equation? Nu is equal to A Z minus B whole square. In the given calculation, instead of frequency, they gave wavelength. See here, what is the relation between frequency and wavelength? Frequency is equal to C by lambda. C by lambda. And see here, that is equal to A Z minus B whole square. Let us substitute the values. What is the value of, see here, 3 into 10 to the power of 8 meter per second, and the wavelength, given wavelength is 1 by 3 angstrom. See here, 1 angstrom is equal to 10 to the power of minus 10 meters. That is equal to, what is the A value? The given A value is 5 into 10 to the power of 7 hertz. And Z, we don't know Z value, we have to find out this one, and given B value is 1. Let us simplify this one. See here, if we simplify this one, here we will get 9 into 10 to the power of 18, that is equal to 5 square in the sense 25 into, here it is 7 2s are 14, Z minus 1 square. See here, if you take Z1 square, Z minus 1 square, that is equal to 9 into 10 to the power of 18 by 25 into 10 to the power of 14. 10 to the power of 14. That is equal to, see here, if you take this one as Z minus 1, then here we will get root. Then it is 9 by 25 into 10 to the power of 4. And see here, that is equal to root 3, root 9 is 3 and root 25 is 5, and here root of 10 to the power of 4 is equal to 10 square, and here we can write this one as 100, 5 ones, 5 20s, and 3 20s are 60. Z minus 1 is equal to 60. Therefore, Z is equal to 60 plus 1, that is equal to 61. Then the atomic number is 61. Once we check this one, here they are asking atomic number. We have to find out atomic number by using the constant values A and B, and here they give wavelength, that is 1 by 3 angstroms. Using Moseley's equation, we substituted the values, and finally we got atomic number Z is equal to 61. And here we learned these things. Using Moseley's equation, we can find out atomic number, and we can find out frequency and also wavelength. And the plots related to Moseley's equation and numericals related to Moseley's equation is very important for JEE and NEET. And actually, generally, the students will focus on Moseley's atomic number and Moseley's classification of elements. They will focus on limited things, but beyond that one, we have many more things. Just now we learned those things. What is the relationship between frequency and atomic number, and how we calculated wavelength using atomic number, how we calculated atomic number using wavelength. These are all possible using Moseley's equation, that is nu is equal to A Z minus B whole square. Okay, and don't neglect Moseley's equation. It is very important for our JEE and also NEET. Okay, and please learn all these things, and don't forget to like it and share it. Please subscribe to our channel, Mr. Chemistry. Thank you.